Hi, today's lesson is on function operations. So what a function operation is these are general functions. They apply for everything because what they figured out is that you can add, subtract, multiply, and divide anything you want, basically. And that's what this is going to cover. So if we say what is the sum of this one and this one, all we do is we're asking what is f of x plus g of x. So we just plug them in. So 3x plus 4 plus x squared minus 5x plus 2, and combine like terms. So x squared minus 2x plus 6. And we're done. Go ahead and try this problem. Same with subtraction. The difference, basically they're saying what is f of x minus g of x? So we go 3x plus 4 minus x squared minus 5x plus 2. If you notice, I did parentheses this time, and that's because of the minus, because we have to change all the signs in the second one in order to get it correct. So now we're going to go negative x squared plus 8x plus 2, and that will be your answer. Go ahead and try this one. Okay, to multiply functions, same thing. We got the g of x times f of x. So we put parentheses. We just put them next to each other. Now we're going to go ahead and distribute and solve. Before I get started though, if you notice, this is out of standard notation. So I'm going to put it in standard notation just to make life just a little bit easier. So if we distribute this, we get 2x cubed minus 4x squared minus 4x squared plus 8x, negative 5, so negative 10x plus 20. So we get 2x cubed minus 8x squared minus 2x plus 20. And there's your answer. Go ahead and try this problem. So dividing functions, basically, we're going to write it as f over g. So we're going to go x minus 7 over 2x squared minus 13x minus 7. So just like with the rational expressions, we have to factor and then see if we can cancel. So this factored ends up being x minus 7 over x minus 7 times 2x plus 1. So these cancel, so you're left with 1 over 2x plus 1. Go ahead and try this problem. That brings us to composite functions. What a composite function is you're plugging in one function into another, or the solution of one into the solution of another. So, first thing we're going to do is we're going to go inside out. Okay? So if they give you a number, work on the inside. So we're first going to find g of 3. So g of 3, we just plug in for x here, so it's 3 plus 1, which is 4. So now we can find f of 4, which means take 4 and plug it in for x. So we get 4 squared, which is 16. That's how you do it with the numbers. How to do it with this one, g of f of x, is rewriting it. It's actually not solving it. So we're going to start with g this time, because it's on the outside, and we're going to put parentheses wherever there's an x. So this ends up being parenthesis plus 1. Notice it said x plus 1, so I'm doing parenthesis plus 1. And then f of x, I'm literally going to copy it in the parentheses, so x squared. So this ends up being x squared plus 1. And that's it. Try this one. So another way of writing the composite function, they have a couple forms, is f with the little circle and g of x, or f of g of x, where it's inside of it. The one I prefer is the one on the right side. That's the one I prefer the most. But it's shown both ways, so just be mindful of that. So with this f of g of x, or fog, I guess, I'm going to write it as f of g of x, because that's how I think of it. So if we're going to write a new rule, in other words, we're going to plug one into the other. The f is what we write first, so square root, and wherever there's an x, put parentheses. So notice, I wrote the same thing, but instead of an x, I put parentheses. And now since g is on the inside, I put g inside there. So 2x minus 5. So if we do that, we simplify it. We get 2x plus 2 under the radical, and we're done. That is your answer. You must clean it up and simplify it at the end. Go ahead and try this problem. Now let's do it for a little bit more of a difficult one. So once again, we got f of g of x, so f of g of x. So when it's f, it's got multiple x's. So what we're going to do is we're going to put parentheses for each one. So parenthesis x squared plus x plus 2. And now, notice it's x squared, x, 2. Now inside each of those, I put 4 minus x for each parentheses, because that's what g of x is. And now we clean this up. So 16 minus 8x plus x squared plus 4 minus x plus 2. Now clean this up, write in standard form. So x squared, how many x's do I got? I got that one and that one. So negative 9x, 22. And we're done. That's it. No factoring, no nothing. Go ahead and try this problem.